Think about your typical workday. If you really break it down, how much of your time is actually spent making those high stakes decisions? I had a realization recently. In the corporate world, 90% of what we do is basically an algorithm. We receive a piece of information, we check it against a set of rules, whether it's actual tangible rules that we can pick up and hold like SOPs, or maybe something that has been told to us over time. And then we just route it somewhere else. We act like human routers. We aren't really making a lot of decisions, we're more just executing a process. For the last few years, we've been using AI to help us type faster or summarize those long spreadsheets, but right now we are genuinely crossing a threshold. We are moving from AI that answers questions to AI that actually executes on vast amounts of work. So it's a true shift from single-use AI to almost agentic coworkers. And I know that sounds sloppy, like what does agent mean? But what it really comes down to is how much time do you actually need to be in the loop? You know, when you're communicating with your AI system, is it every 2 minutes after a prompt comes back? Is it every 10 minutes because it has a small set of tools? Or is it every 10 hours because it has all the resources to everything it would need, and then each day it just needs a daily checkoff, you know, if it did the right thing or not. And by taking the human out of the loop for the boring stuff, and this is going to fundamentally change what it means to work. Think about it like this. Maybe your morning consisted of clicking on a few emails, responding, going on a few softwares, tweaking some things up. What if you were able to only make those decisions from one streamlined place and you were just provided options? You'd probably save 90% of the time, and you would be at the absolute highest level of just deciding between a few things because your AI system already recognizes what you like, what you don't like, and is able to easily serve to you the few decisions that you would actually make in this position. So to understand where we're going, we have to look back at where we've been. Until now, our relationship with AI has been a single-turn interaction. You type a prompt, you get a response, it's a straight linear line. But unlike these non-agentic systems that provide simple linear responses, agentic architectures support dynamic, multi-step processes where agents can adapt to new information and learn from outcomes. So what has really been the unlock for me is seeing how if you connect real-world events such as metrics, KPIs, and use that as the North Star for your AI system, it's able to actually look at what its impact is and then reiterate on its own data. Because there will always be an edge case. This world is not finite. No scenario is always the same, and things always change. And that's what we saw with deterministic workflows in software all the way up until the AI boom. It was great, but it only can execute on one thing, and if anything changes, the system just breaks down. So there's a fine mix between determinism and probabilism that AI gives us to come up with agentic systems that don't break down under pressure and are able to make decisions in a reliable fashion. They don't just wait for you to ask the next question. They operate on what computer scientists call the sense, plan, act cycle. An agent senses its environment. Maybe it reads a new customer support ticket. It plans a strategy to fix it, breaking the problem down into subtasks. And then crucially, it acts by making decisions, like calling your company's database API to check an order status. Then it reflects on what just happened. Did the database search fail? The agent will realize that and then rewrite its entire query and try again, completely autonomously. It actually has agency. That's where the word agentic or agent comes from. But how do you actually build a digital worker? You can't just give ChatGPT access to your bank account and hope for the best. And also, it wouldn't work. There's a really great chance that it wouldn't just drain your bank account and send it to some Russian hacker. But the point is that these AI systems break down so quickly if it is purely probabilistic. So the question is, how can you force an AI system to become more deterministic? To do this, scientists deconstruct an agent into a system theoretic framework. A robust agent is an organization of distinct systems. First, you have the perception layer. This is how the agent gathers data from the outside world. Second, the reasoning layer. It's almost the brain that uses large language models to understand the context and create a strategic plan. Third is the action layer. And this is the hands that actually use the external APIs or the tools in order to make real-world actions. And finally, memory, both short-term to manage the immediate task and long-term to remember past experiences, user preferences, and company information. And here's where it gets really interesting. Because you don't just have one agent, you can build an entire digital company with what's called a coordinator pattern. Here's a scenario. Let's say a customer requests a refund. In a coordinator pattern, a central AI agent acts as the orchestrator. It receives the email, analyzes it, and delegates subtasks to specialized worker agents. It then sends the receipt to a verification agent and the customer profile to a refund eligibility agent. The coordinator then waits for its workers to finish, synthesizes their findings, and then prepares for the final action. And then what did the human do in this loop? The human just got a notification that says refund processed, and all the rules were followed. And see, this saves so much time at any company. And maybe you're thinking, well, this is such a small edge case scenario of a refund process. How does this actually change the world? Well, over 70% of Americans rely on computers to do their day-to-day work. And all of these interactions with our computers are all these monotonous processes that could be done by our agent. So at a macro scale, companies are figuring out how they can wipe out entire divisions and replace it with AI. And on a micro scale, you can wipe out hours throughout your day of monotonous tasks by setting up these types of agentic systems. And this now begs the question of job loss, which is extremely valid. But I'm gonna actually leave that up to you. But here's the catch. Real world business is messy. Rules change, edge cases happen. If you have to manually reprogram these agents every time something happens, they become a massive burden rather than actually helping you achieve the goal you intended on. So how do the best AI systems handle this? Think about self-driving cars. They don't get better with engineers sitting in a lab writing code. They improve by driving millions of miles, capturing weird edge cases, and then feeding that data back into the model. And this is what's called a data flywheel, and it's something I'm so interested in. A data flywheel is a self-reinforcing cycle where each new data point enhances the system, gives it more context, and overall improves performance. So as your AI agents interact with your business or you interact with agents from other businesses, they capture real-world production data. When an agent makes a mistake, a human corrects it, and that correction doesn't just fix that one issue, that interaction is automatically curated and fed back into the model to fine-tune it. And this is the massive difference. This is what is changing so quickly. It's that the AI is able to actively reflect on its actions in the real world. So every failure is a lesson. The cycle runs continuously. Accuracy goes up, costs go down, and the AI system literally evolves with your business instead of lagging behind it. Okay, so this all sounds like corporate utopia, right? Sit back, let the flywheel spin, and let all the agents do the work. But I promised you, it's reality, not hype. The truth is, experts predict over 40% of agentic AI solutions are going to be out of business by 2027 because autonomy is dangerous if you can't observe it. So when you let AI agents talk to each other, you run the risk of infinite loops. Imagine Agent A analyzes a report, and Agent B's job is to validate it. Agent A sends it, Agent B says, needs work. Agent A refines and resends. Agent B then rejects it again. Because neither has a termination condition to say, we're done here, they literally get stuck in a conversational deadlock. They spin endlessly and just burning AI computing costs, and overall just crashing your system. But infinite loops are just a bug. There's many ways that researchers and people have been finding to mitigate it. Like I've been using a tool called Langfuse that essentially allows you to look into what your AI interactions are doing. So from the input all the way to the output, you can see what happened in the middle, what tools it used, the amount of tokens, the amount of errors, and then you start to actually see and pinpoint what things need to be fixed with the overall system itself. But there's a much more insidious threat to autonomous AI. It's called a logic breach. Data poisoning is a silent threat that targets the infrastructure of enterprise AI. Attackers don't need to hack your password. They just subtly manipulate the training data or feedback loops that the agent relies on. Because of the data flywheel we just talked about, small and intentional manipulations can result in massive bias in the overall system. The model reinforces incorrect patterns through repeated learning. And the AI system isn't broken, it's actually doing exactly what it was supposed to do. But it has been taught the wrong objectives. So it's a logic breach where systems continue to function. So how do we actually fix this? We implement what's called agentic observability. So agentic observability means getting visibility into the internal states, decisions, and performance of the autonomous AI agents as they operate. So you don't just monitor the system if it's turned on or off. You trace why the agent made a specific decision, what data it looked at, and what tools it used. We establish hard turn limits to stop infinite loops. We put human-in-a-loop checkpoints for high-stakes actions, and we ensure that AI is grounded in strict, structured enterprise data. And this brings us back to where we started. If we build these systems correctly and with the right observability and the right guardrails, we are not just automating jobs away. We are automating the algorithm out of human experience. When you remove 90% of your day-to-day copy and pasting, routing, and checking boxes, what are you left with? You are left with judgment, empathy, strategy, creativity. These are all the things that AI cannot do. So we are handing the execution over to the machines so that we can finally spend our time making decisions, which is what actually matters. I'm William, and thanks for watching.